Hi, I'm Ms. Boom, and today we're going to be looking at rates of change, and we'll be using the CAS calculator, so have it ready. We'll be using the average rate of change, that is y2 minus y1 over x2 minus x1, and we've written it as a function notation since last year, so y2 will be f of b and y1 will be f of a, and then the x values. We'll also be using the instantaneous rate of change, which is the derivative at a particular point. So average, instantaneous. We're going to answer one very large question, an exam style question. Here's the example. The height above the ground hm of a skydiver between the times 0 and 50 seconds jumping out of a plane is given by this equation. So a skydiver means it starts somewhere high, jumping out of the sky means after some time the height is getting smaller and smaller and smaller. Find the average rate of change, hm, between t's 1 and 3. So before we start, we're going to use the CAS calculator and define our equation. I'm just going to put the calculator there. So at first we go to main, action, command, define. So we're going to use the same letter. So go to ABC for the letter of the function because it's not a variable. And then open bracket, we're going to use the x down here as our variable, equals 4500 minus, so far straightforward, 500. E is up here to the negative 0.14 t or x. Now, it's important that you hit that button there to the right so that you go down and you're not typing within the power of e. So minus 70x. And you can tell because the 70 looks pretty big and it's not next to the 4.14. Hit enter. Now the calculator knows that that is what h of x means. So the average rate of change is going to be h3 minus h1 over 3 minus 1. So let's find that out. So the math one gives us the fraction, or you can do shift divide, same. So h3, I like to drag and drop, it's just a bit easier, minus, and then after I drag and drop, if I manage to do it, I'd like to change the value from in there. So 3, 1, and we know 3 minus 1 is just 2, so just write that in there instead of typing everything, and we have minus 16.922. Negative 16.92 is the average rate of change, so it's going down, that's why the velocity is negative. B, find the velocity at function t. Now the velocity is the derivative of ht. So we go to our CAS, we find the derivative button, which is in math 2, ddx, and we're going to drop h of x in there, enter. That looks really scary, so we're going to go to standard and do it again. That looks much better. We can also derive it by hand, so let's have a look. Oops, wrong one. So we have, let's have a look. That number disappears. Minus 500 times minus 0.14 is 70. E to all of that. And then minus 70t is just minus 70. Okay, part C, find the velocity of the skydiver at 2. So the velocity, we have the equation and we have it in our CAS. So all we have to do is substitute the 2 where x is. So let's do that. So all of this, and you can do shift comma to bring up the bar, it's much faster. X equals 2, enter, and again we want it in decimal form, so highlight that again, click enter again, and it should give you minus 17. So write the answer in. And in your calculations, you do not need to write all of this, you can just write v2, then we know that you're looking at the velocity at 2, as long as you've given the velocity equation just before that. Find acceleration a as a function of t. Now we know the acceleration is the derivative of the velocity. So we're going to derive it again. So 70 times minus 0.14 is minus 0.98. And minus 70 is a constant, so it disappears. Again, we can bring out our cas, and how do we do that in here? We derive the derivative. So, oops, derive, and the derivative is, if you hide the keyboard, it's easier to see. The derivative is up here. So put that all of it in, enter, and put it into standard, and we get that. And as a decimal point, minus 49/5 is our 9.8 over there. So you can have a look at that, try it out, pause the video, make sure that you get the same answers. Part E, find the initial height of the skydiver above the ground. So initial means when time is 0 or x is 0, and height means which equation will we be using, the original equation. So in your working out, you would write h0, and then you go to your cas and then type in h0. So h, and put a 0 in there, enter, 4,000. And the units are meters. Part F, find how long it takes to fall to half the initial height. So half of 4,000 is 2,000, that's h. Now we're looking for t when h is 2,000. So h is 2,000, what is t? Well, the easiest way to do this is to use the cas again. So bring out the cas. So when h of x is equal to 2,000, what is x? And to do that, we need to go to action, solve, advanced solve, and we're looking for x. So the right x there. And we have minus 13. Now time is not negative, so it's a 35.66. So 35.7 seconds. Part G, sketch the graphs of h of t and v of t between 0 and 50 seconds. So the height, I've gotten it here in blue, and the velocity is in red here. It's hard to see, but you can tell that from the graph, you're going for a negative gradient and more and more and more and more negative. So it's closer to 0 here, and it's a bigger negative value there. And you can see that the velocity is closer to 0 here and more negative there. It's very hard to see because the values are much smaller than the thousands, like the height. Let's have a look at it, how to do it on the CAS. So we go to, graph and table. Then you can go to keyboard, ABC, H, type in h of x, enter, because your CAS knows what it is, you've told it to. Now to do the interval, you do shift, comma, so it brings up that bar there, and then 0, go to math 3, less than x, less than, we'll do less than or equal to 50. In case we need to calculate endpoints, it's always good to include that. So enter, graph, see it cuts off over there in that corner. If you don't include 50, if you need to find an endpoint when you do gsolve, it might not do it. So always include 50. And the vertical bar, again, shift, comma. Now to find the velocity, we can type in the derivative. So keyboard, where's ddx in math 2? ddx, and drop in our h of x. Again, drag and drop is always good. Enter, graph and tab, and we can see the red line over there. Again, you can copy paste the interval, shift command for the vertical bar, and then it should cut off over there. See? Now the zoom auto is not bad, and then you can use this arrow button to put in the interval. So we can see that our maximum value is going to be in the 1,000, so Y max can be 4,100 to see it better. So change your things in there in the arrow section. Okay. Part H, describe the skydiver's velocity as t increases. So as we go that way, what happens to the red line? We can see that it's getting more and more and more negative. The value is getting bigger, but in the negative direction. So we write velocity is increasing in the negative direction as t increases. At 50 seconds, the skydiver opens the parachute to prepare for a safe landing. The equation is the same. Find the height above the ground when the skydiver opens the parachute. So when they open the parachute, t is 50. So in other words, your working out should read h of 50. Now then you can go to your CAS calculator and you can do this in two ways. Make sure you're familiar with both ways because there are reasons to use either in different situations. So one of them is to go to Graph and Tab. Make sure you have the graph there. So click Graph. And then Analysis, G-Solve. We're looking for the height, so the y value, not the x. And it's going to ask you which equation do you want. It's going to flash, is it the blue line? And if the answer is yes, press enter. If it's not, then you can go down and it'll flash the other line. See? Now going back up, it goes back to the line I want. So hit enter and it's going to ask you at x equals what? And we know it's 15. So write 15 there. Hit enter and now we have y value is down there, 999.54. You can also go to main and type in h of 50 and make sure it's in decimal, enter, and it gives us 999.54 as well. Part J, find the skydiver's velocity as the parachute begins to open. So the v when t is 50. So writing that out, v when t is 50. So v is, again, you can go to the graph, make sure the graph's there, and now analysis, G-Solve, what is v? So the y value for this other line, so click down, it will flash the velocity equation, and 50 for x, and it gives me 69.936. Or you can go to main, and it is the derivative of h of x. So math2 dt x h of 50 enter. Oops. Sorry, h of x derivative, and then find this shift comma when x equals 50. So again, negative 69.94 rounded up meters per second, 69.9. That's it for me today. Try using the CAS, get used to it. I've made a couple of mistakes here and there. Make sure that you practice enough so that you can fix your own mistakes. Most of the time it's just forgetting to go left or right on the CAS, these buttons here, and not using the correct equation, or forgetting to go down from the power of an exponential and typing in part of the terms into the power instead of going down. So these buttons very handy, and the enter button very handy. Practice and get used to it, and I'll see you next time. Bye.